So let's find the area inside the loop of this Limacon with a loop. This inner loop Limacon, that's literally what it's called. So the equation is r equals 1 plus 2 cosine of theta. So we want to figure out this area in here, which means that we need to figure out what two angle values it's in between. So it looks like it's happening when it goes through the pole. So let's see if we have let's see, we'll plug in some theta values. I just want to see where it starts first. So maybe I plug in theta of 0, so that's 1 plus 2. Cosine of 0 is 1, so that's going to give me 3. Okay, so out here at 0, we are at 3 comma 0. Remember, 0 is the theta value. Okay, so then let's go to another one that's easy to plug in. Let's go to pi over 3. Okay, so pi over 3 has a cosine of 1/2. Right, so 2 times 1/2 is 1. 1 plus 1 is 2. Okay, so this is pi over 3 up here. Okay, so we're going in this direction around the curve. So then another easy one to plug in would be pi over 2, right? Cosine of pi over 2 is 0, so this is going to be 1. Right, so this is 1 pi over 2 in polar coordinates. Okay, let's see. Let's plug in 2 pi over 3. So 2 pi over 3 has a cosine of -1/2. That's going to give me 1 minus 1 there. So that's going to give me 0. Okay, so that's where we first hit this, is at 0, 2 pi over 3. So the next one that's pretty easy to plug in would be pi. So pi, cosine of pi is -1, so that's going to be 1 minus 2. So that's -1. So that actually is this point here. This is -1 comma pi, because you go out to the pi angle over here, and then you go back -1. So that is there. So it looks like we're probably headed like this because polar curves are smooth. So we're going in this direction around the curve. And then the next easy one to plug in, so the pi over 3 mark down in the third quadrant, is going to be 4 pi over 3. So again, that's going to be cosine is -1/2. 2 times that is -1. 1 minus 1 is 0. Okay. So we come back around this way and hit it again at 0 comma 4 pi over 3. So that means the angles we need are 2 pi over 3 and 4 pi over 3. So this is our interval here. So we're going to go ahead and find that area. So area is equal to 1/2, 2 pi over 3 to 4 pi over 3. And then we're going to square this out. So we have 1 plus 2 cosine of theta squared, d theta. Okay, so we're going to square this out. So we're going to get 1/2 integral of 2 pi over 3 to 4 pi over 3. That's going to give me 1 plus 4 cosine of theta plus 4 cosine squared of theta, d theta. So the first two terms really easy to integrate, so let's go ahead and integrate those. So we're going to get 1/2 times theta, let's see, and that's going to be plus 4 sine of theta, evaluated from 2 pi over 3 to 4 pi over 3. I'm just going to go ahead and make a little bit more space for myself here. Let's just move this over. And then we need to add, let's see, we're going to do 1/2 times 4 is 2 pi over 3 to 4 pi over 3 of cosine squared of theta, d theta. So remember, we've talked about this before. We're going to use this cosine of 2 theta identity. That's equal to 2 cosine squared of theta plus 1. Pretty sure it's plus 1. Quick check my notes before we go down the wrong path. Nope, it's -1. That's what my gut was telling me, but I was like, no. Okay, right, and that tells us that cosine squared of theta is equal to 1/2 cosine of 2 theta plus 1, right, if we solve that for cosine squared. So I'm going to go ahead and substitute that in right here. So I'm going to actually delete this out, and we're going to put in 1/2, right, and then we had cosine of 2 theta plus 1 in there, d theta, right, and that's the same thing as cosine squared. Okay, so I get 2 times a half there, so those things are going to cancel out. Awesome. And then, okay, let's see. Let's go ahead and evaluate this first part. So I'm going to get 1/2 times 4 pi over 3 plus 4 times sine of 4 pi over 3 is going to give me negative root 3 over 2 minus 2 pi over 3 plus 4, and then 2 pi over 3 has a positive sign of root 3 over 2. So there's my first two parts. Okay. Now I'm going to go ahead and just break this into two integrals. So I'm going to integrate the 1 next. I will do that in purple. So the integral of 1, that's going to be theta from 2 pi over 3 to 4 pi over 3. And then I still need to integrate 2 pi over 3 to 4 pi over 3 of cosine of 2 theta, d theta. Right, so we're going to use u substitution on that 2 theta. So du is 2 times d theta. So I want to use a 1/2 du here to replace my d theta. Okay, so I'm going to have 1/2. Let's see what this is going to be. So this is 4 pi over 3 minus 2 root 3 minus 2 pi over 3 minus 2 root 3. Okay, so 4 pi over 3 minus 2 pi over 3, that's going to be 2 pi over 3 minus 4 root 3. Okay, so we have that part plus we're going to get 4 pi over 3 minus 2 pi over 3 for evaluating the theta part. So that's going to be another 2 pi over 3 plus we're going to get 1/2 times the integral from, let's replace our limits of integration. That's going to give me 4 pi over 3 to 8 pi over 3 if I replace my limits of integration into u equals 2 theta, and then cosine of u du. Okay, so keeping that up, we have, that's going to be pi over 3 minus 2 root 3 plus 2 pi over 3 plus we're going to get 1/2 times the sine of u evaluated from 4 pi over 3 to 8 pi over 3. Okay, so overall in the front, I have, this is going to give me pi. So we get pi minus 2 root 3. Don't like the way those lines look since they don't actually line up. There we go. Okay, so plus 1/2. Okay, so sine of 8 pi over 3. 8 pi over 3 is the same thing as 2 pi over 3. So 2 pi over 3 has a sine of root 3 over 2. And then sine of 4 pi over 3 is negative root 3 over 2. So we have 2 of them. Right, so overall this is going to equal just root 3. And then that's going to be times 1/2. So, okay, we got pi minus 2 root 3 plus 1/2 root 3. So that's going to give me pi. That's minus 4 plus 1. That's minus 3 root 3 over 2 as our area inside the loop of that curve.